Hello and welcome to R&D Mathematics. Today we are going to talk about radicals and rational exponents. Now, first of all, radical. This sign we call it a radical. And whatever inside this part we call it radicand. And altogether this is a radical expression, right? That is the idea. Now, first thing to note, with this radical sign, if you put n here, let's say 81, and that means 81 raised to 1/nth power. Simple as that. So if you have 4 of x, this is x raised to 1/4. If you have 5x, this is x raised to 1/5. Now there is a special case when n equals 2. You have to be careful here. That is how people have been writing it. Now for 2 we don't normally write a 2, because when you see this, you know this is square root of 25 or this is square root of 2. So n equal 2 case you don't write it. So if you don't see something here, that means, for example, if you see x, that means x raised to 1/2 power. So there is a little bit notation confusion that happened over history anyway. So remember that if there is nothing, this means 2y whole thing raised to 1/2. On the other hand, if you want to write down square root, normally we don't do this. Square root of x, normally we don't do this. We write it without that. So that's a special case. And there is another thing too about notation. What if you had 25? This means we are looking for a number. When you square it, you get 25, right? So there's a slightly, this place you have to clearly understand. Now I wrote down two things. What do you think? Are both of them right or both of them wrong? Or one of them right? Well, in this case, this is the right answer. This is wrong. The reason is, see, sometimes we write plus or minus 25. If I write that, that means I'm talking about plus or minus 5, right? So if I want to specify that I'm talking about the negative part of that, I have to put negative. And if you don't put a positive, if you just put your sign, that means you're talking about positive. Exactly like, see, when you write number, let's say number 3, when you write number 3, you don't normally write plus here to indicate that's positive, right? You just write 3 or 8 or 7, right? And if it is minus, yes, we put a minus, negative number like this. But for a positive number, no, normally we don't put a positive sign exactly like that inside in front of a radical sign. If you don't see any sign, that means we are only talking about positive part. That's another place to understand. Now let's have a look at simplifying some radical expressions. Well, you have to be a little bit good with numbers. This is 10. And how about this? Well, first, inside the first guy, this guy, that's 4. And this 2, right? And how about this 20? Well, can you see, I'm trying to address, can you do this? Nope, you cannot do this. We can check. Actually, the way to go is you have to add this first. That's what it says. You add it first, 169, then take the 1/2 for square root, and that's 13. Now, if you check this is 5 and this is 12. When you add it, you get 17. See, this is wrong. You cannot break it like that. Remember that, right? And how about multiplying? A times B, this is, can we break it? Well, with multiplication, yes, you can break it. Now let's see some examples, then you will easily understand this. How about square root of 16? Well, you all know that's 4, right? But 16, the number 16, I can write 4 times 4, right? Now, according to this rule over here, my A is 4, my B is also 4. So 4 into 4, let's see whether that works. 2 times 2, which is 4, same as here. See, this is true. So remember, even though you cannot break it with the positive or plus or minus signs, with the multiplication and division, you can actually break it. That is really helpful when we are simplifying expressions. Now let's see an example. How about if I ask you to simplify these? A to the 5th, B to the 4th. Now, in order to simplify this, do you see anything? I have to be very careful now. According to that rule, I can do this. B to the 4th, right? So I am isolating the separate terms. Now this guy, B to the 4th, and the square root of B to the 4th is B squared. Square root of A to the 5th, how do you deal with that? Now let me take it over here. And A to the 5th means actually you have 5 A's, right? Oh, A to the 4 times A, right? Now A to the 4 and A to the 4, square root of it is A squared and A. So this guy is actually A squared comes out and you have A, that's A to the 1/2 power. And how about this? Is that a nice number? Well, if you cannot at one shot identify, this is, it ends with 2, that's an even number, so I can divide it by 2, so 2 times 81. Now 81 is a nice number, so this guy, square root of 2, square root of 81, and A squared, square root of A, B squared. Now square root of 81 is 9, so 9, let me write down the nice numbers first. A squared, let me write down B squared. Only remaining two things are inside the radical. Again using the backward of our earlier result, I can write this as 2A. See, you should be able to do a simplification like this. And let's see more examples. How about this? Let's say (234) x to the 11 y divided by 26 x to the 7 y whole thing radical side. Now look at these numbers. One thing you can do, first simplify inside. Before you touch the radical sign, just write a big radical sign and try to simplify this guy. So leave radical there. Okay, how many x's? We have 11 on top and 7 on bottom. Now this is, if you struggling with exponents, watch my previous video. X to the 11 minus 7, so you have 4. Y's will nicely cancel, so assuming y is not 0, but anyway, y is 0, everything is 0 and it doesn't make any sense. So y is not 0 in this case. And these numbers, now we only have this and this. Will they simplify 26 and 200 and I see number 6 here and number 4. How about 9? Will that work? 9 times 6, 54, 5 left. 9 times 2, 18 and 5. Yes, see. So this will cancel and take. It is 9. So what you have is this, and here just 1. And when you simplify this, 9, square root of 9 is 3, square root of x to the 4th is x squared. So this is our answer. Now how about this example? 5 plus. Now when you look at this, it seems like that you cannot do anything, but actually you can. Now when you have to add radicals, see how, okay, the common mistakes. 7, 12, 3, no, this is wrong, right? You cannot add like that. Now what you need to do, 5 and 2, see this number here tells you have 5 of these guys. This number here tells you you have 2 of these guys. So there's no way that you can add directly unless you can make these two guys into some common ground. Now let's think. 12 is actually 4 times 3. Now we have some hope. Why? Because we have 3 here and we have 3 here as well. Now if you can simplify this, so this becomes 5 times 4 times square root of 4 times square root of 3. Square root of 4 is just 2 and 2 times 5 is 10. So 10 root 3. Now we can simplify. Why? Because we have 10 of root 3, we have 2 of root 3, altogether we have 12 of root 3, and that is how you simplify. Now next we'll talk about rationalizing a denominator. Rationalizing the denominator. Denominator. Now let me take an example and teach it to you. Now what do you mean by rationalizing? That means we are getting rid of this radical sign. It does not look, it doesn't look nice. I mean, okay, let me teach you how to do this, and later you will understand why we are doing this, but for the time being, let's be technical. Now the easiest way for me to get rid of this square root 10 is to multiply that by another square root 10. Then it will give me a 10, right? Because square root into square root, basically what I'm doing here is 1/2, that's this guy, and you have another guy, so square of them, the squares will cancel and you get 10. But when I do this, I just cannot do it like this. I have to balance it by doing this. See, what I am doing here, I am multiplying top and bottom by the same number. So basically this number in green color circle is 1. Can you see that? Because it will see, whenever you have some number, you can just multiply it by 1 because it will give you the same number. So here what I'm doing is I'm multiplying it by 1, but in a nice tricky way. 1 is same number over same number, right? So when I'm multiplying it by square root of 10, it will get rid of my radical sign in the denominator. But I will have a radical in the numerator, so it's 3 times. I can now put everything inside. So the answer here, 2 times 5, so square root 30 over 15. I hope that is clear. Now let's take a little bit more advanced example about rationalizing the denominator. What if you had to rationalize this? Now in this case, it does not work like the other one. There is an easy technique. The reason behind this technique works with a formula square difference between two squares, factor in a plus b into a minus b. Now using this, we'll talk about this in detail later. What you need to do, you need to multiply by the conjugate. What do you mean by conjugate is 1 plus square root 5. I'm going to multiply this by 1 minus square root 5. And if I do that, I have to do the same thing over here. Okay, now let's see what's going to happen. 4 times 1 minus square root of 5. Now using this formula over here, see a plus b, a minus b. 1 plus root 5, 1 minus root 5. And that's going to be a squared minus b squared. So in this case, 1 squared minus root 5 squared, which is root 5 squared, which is 5. So you have 4, 1 minus root 5 divided by 1 minus 5, which is 4 or negative 4. So 4, 1 minus root 5 divided by negative 4. So 4's will cancel and there's a negative. When you take that negative inside, you get this. And that is the simplest form. Now let's see more examples, a little bit more examples before how about, let me give you an example. How about this? So far we have been talking about square roots. Now roots with different numbers. Now this means 8 raised to 1/3. So the question is there a number? Well, there is a number, of course. Same number, when you multiply 3 times, that gives 8. And yes, that is 2, right? (32 raised to 1/5 power, and that is also 2. Now there's a little tricky place to how about this? Let me go to the how about this? Let me put 3 parts. Maybe 4 parts. First one, part A. Square root of a negative number. Now think about this. When you multiply any two numbers, when you multiply the same number twice, or a squared, that's always positive, right? It will never be negative. Because of that, this does not exist. Now let's go to part D. A times 8 times 8 times a, that's a to the 4th power. That is also always positive. So this also does not exist. So remember, even root of a negative number does not exist or is not real. It is complex numbers, that's a different story. Negative, even root of a negative number is not real. Now let's talk about these two. How about an odd root? When you multiply a, can I get negative? Well, yes. Why? Because negative into negative into negative is always negative. So in this case, the answer is negative 2. Now think about this. Negative 2 into negative 2 into negative 2 is negative 8, right? See? These and these are same. Now, this one, when you multiply a certain number, well, yes, this exists, but you need a calculator to find this because all I can say at this point, this is a number between 1 and this should be, let's say, 2 times negative 2 times 5 is negative 32, negative 2 raised to negative 32, and negative 1 raised to 5 is negative 1. So that is negative 1 point some number, but it exists. So the point here is to understand even root of a negative number does not exist, odd root of a negative number exists. And how about this example? What does this mean? This means if I try to put a radicand sign and deal with this, so 32 1/5 power whole thing raised to square, that's what it means. Oh, in other words, 32 squared, that raised to 1/5 power. That's what it means. So there are different ways of putting the same thing. So one way of putting this guy into radicand is 32 squared of this. Or the other way of putting this is 32 to the 5th and then square root. So I like this one, last one. So 32 1/5 power, that's 2. So 2 raised to 2, the answer is 4. Or if you want to simplify with this, it's the easiest way to go with writing it like this. So 4, sorry, not 4, 2 raised to 2, that's 4, right? So what we basically did was actually this. A to the m over n is same as m and n are going to appear in this equation. Can you figure it out? Pause the video and try to think. Here n, here m, with a parenthesis, right? O, a to the m, and you take nth power. They are the same. Think about it. Think about it for a while. Okay guys, I think that's enough for today's video. Thank you.